illustrate how the output voltage responds concerning change in the input voltage in a specific electronic component circuit. In this graph, the cutoff region reflects the state where the output voltage remains nearly constant despite variation in the input voltage. The region occurs when the input voltage is below a certain threshold level. The saturation region signifies the state where the output voltage remains constant despite further increase in the input voltage. This occurs when the input voltage is above a specific saturation level. The threshold voltage in this graph represents a transition point between cutoff and active region. At VTH, the output voltage begins to respond noticeable to change in the input voltage. The linear region on this graph signifies a range where the output voltage responds linearly to variation in the input voltage. A change in input voltage leads to a proportional change in the output voltage, and this region is represented by a linear slope or a curve on the graph.
Response refer to the initial behavior of a dynamic system following a sudden change or disturbance in its input. This analysis supposedly makes the Vin be smaller than the Vout, and the gain must be 1 or more than 1. But in this lab, we got Vout is smaller than the Vin, and this result also shows that the amplifier may have a gain magnitude less than 1. After doing research, maybe the problem is the circuit might not have reached a steady state. The graph relationship is voltage versus times. When the input is increased and then the output will decrease. Also same when the input is decreased and then the output will increase. Voltage output graph will inverse from the voltage input graph.
AC analysis is used to calculate the small signal response of a circuit. In AC analysis, the DC operating point is first calculated to obtain linear small signal model for all nonlinear components. Then the equivalent circuit is analyzed from the start to stop frequency. Larger RD value increase the influence of the CLM. R0 term begin to strong affect the gain. So in this lab, we use RD equal to 1 kilo ohm, which is a ideal resistance. The feedback network shift the phase of the amplifier output by 180 degrees at the acceleration frequency to give positive feedback, but we get the negative feedback which is due to wrong analysis setup.